Let R be the region in the first quadrant bounded by the graphs of x equal y cubed and x equal 4y. Which is greater, the volume of the solid generated when R is revolved around the x-axis or the y-axis? So first let's draw a picture, and we're just in quadrant 1, so we're only going to just draw quadrant 1 here. And let's go ahead and put the first graph on there, which is x equal y cubed. And I can just plot a few points. I kind of know the basic shape, but if we put in 0, we get out 0. If y was 1, then cube that and you still get 1. If y was 2, cube that and you get 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 and 8 is going to be over here, so this is going to look something like that. Now let's put our other piece on. We have x equal 4y, which we know is a line. If we solve that for y, we would have y equal 1/4 x. Maybe we'll use that for the graphing since we're familiar with that. So the y-intercept is 0 and the slope is 1/4. So we're going to go up 1 and over 1, 2, 3, 4. And that would be a point on that line. So the line's going to come through something like this. Okay, now I don't know, my line looks kind of curved here and I don't trust how I drew this, and so I need this intercept point, and the way I'm going to find that is I am going to substitute, since x equal y cubed, I can put 4y in for the x, so 4y equals y cubed. If I move things over, y cubed minus 4y equals 0. Factor out a y, and that's going to leave me y squared minus 4, and I'm tight on room, so I can see that I'll have y squared minus 4, which factors into y plus 2, y minus 2. So what that tells me is this is going to have intersection points when this equals 0. So this is going to be at 0, at -2, and at 2 for the y values. So this point is a y value of 2, which meant the x value was 8. Alright, so now that we have the intercept points and we can see our region clearly, let's go ahead and think about rotating it. First, we are going to rotate it around the x-axis. So in rotating this around the x-axis, I'm thinking, how will my slices be? And when we're doing the washer method, the slices are perpendicular to the axis of rotation. So I know my slice would be right here as a representative slice. Now maybe I'll make another one up here so that it's not quite as tight to the axis and we can clearly see that we've got a washer going on because we're going to have a hole in the middle. And so my big R, I'm going to make that in gray. Big R is going to be this right here, and then my little r is going to be right here. Now I've separated from each other. They will be at the same point, but just so we could clearly see. So we are going to find this volume, and it's going to be the integral. As we look at this, my little thickness here is a dx on my slice, so I know everything is in terms of x. And so I am going to have my limits go from 0 to 8, because we can see that's what our x's go between for this. And so I'm going to have pi big R squared. Well, big R was the y value up to that upper function, and that upper function was x equal y cubed. But we have a problem with that because we want to know what y is. So we could solve that for y. I'm just going to put it over here. It's y equals x to the 1/3. We just take the cube root of both sides. So that is going to be my big R, so I need to have that squared, x to the 1/3 squared, and then minus pi little r squared, and a little r is the y value for the line. And so if I had that one solved for y, that was 1/4 x. So let's go ahead and put that on. That's going to be 1/4 x, and we need that squared as well, and then dx. So there is our integral, and now we need to compute this integral, and we will have the volume of this rotated around the x-axis. So in order to do that, I'm first of all going to factor out the pi, and that's going to leave me, I still have from 0 to 8. I'm going to go ahead and square that, so that's going to be x to the 2/3. And then minus, I factored out the pi, I need to square the 1/4, so that's going to be 1/16, and then x squared dx. So now I can go ahead and work that integral. So this x to the 2/3 is going to be 1 higher power, which should make it a 5/3, but I need the reciprocal of the power out in front. And then on this next one, it's going to be 1 higher power, which is a cubed, and then I need the reciprocal of that power in the front. So I need a 3 in the denominator multiplied by the 16 gives me that 48. Now that needs to be evaluated then between 0 and 8. Okay, let's go ahead and set this up then to do the evaluation. So I'm going to have 3/5, and I'm going to put in 8 to the 5/3 minus 1/48, and then 8 cubed, and then we can see when we put in 0 that that's going to be 0, so lower limit 0 there. Alright, as I do that now, I want to evaluate this. Remember, looking right here, that this means a cube root and then to a 5th power. So the cube root of 8 is 2 to the 5th is 32. So I would have 32 times 3, which is 96 fifths. And then here I have minus 8 cubed over 48, and that is all still multiplied by pi. So when I go ahead and cube this and get the common denominator, it looks like I get 128 over 15 pi. Now we're also going to want to rotate this around the y-axis, and then we can compare these values. So we will do that next. So we have our same region, but we want to rotate it around the y-axis. So when we do that, our little slices are going to be horizontal slices. Envision this rotated around the y-axis. We can see it would generate kind of a bowl-shaped thing. It would actually have we have this straight line on the outside and curved on the inside. And if we were looking at these little slices, they would be washers. And if we looked at the complete diameter here, we could call that capital R. And then we have the hole in the washer right here. We can call that little r. So let's go ahead and express this volume. It's going to be the integral. Now our little thickness here is a little dy thickness. So we're going to write everything in terms of y. We're going to integrate from 0 to 2 then, looking at our y values. And we have pi. As we look at big R, it would be the x value along this red function, and x equal 4y. So the x is 4y, and we need to square that for pi r squared, minus, now we're going to subtract off the whole, so it's the circle that we would get here by doing pi little r squared, and little r would be the x value of this function, that is x equal y to the third. So this would be y to the third squared, and then we need to multiply by our little thickness dy. Let's go ahead and see what we can do to simplify this. We can factor out a pi, and we've got 0 to 2 of 16y squared minus y to the 6th, and that's dy. So now let's go ahead and do our integration. So we still have our pi, and this would be 16. We need the reciprocal of this power, so over 3 minus, and this would be 1/7 y to the 7th, and then we need to evaluate this from 0 to 2. So that would be pi multiplied by 16 thirds times 2 to the third minus 1/7 times 2 to the 7th, and our lower limit 0, so that part is 0. And when we go to simplify that, that would be 512 pi over 21. So we've got 512 pi over 21, and we could put that in a calculator to get an approximate. That's about 76.6, and that would be rotating it around the y-axis. And we need to compare that to what we got in the first part, and we see that this volume is bigger.